Hello, in this tutorial we are going to learn how to get the first element of an array that fills a given criteria. This criteria will be specified by us. We are going to do this using an operator from the cpplinq library, which we already have started covering in a previous tutorial, a very simple one, and now in this tutorial we are going to start to check some more advanced use cases. So this code will work both on the ESP32 and on the ESP8266 because cpplinq is a generic C++ library. Here I'm going to show you the results in ESP32 board, so a FireBeetle board, ESP32 FireBeetle board from the FRobot, but I've already tested this code on the ESP8266, also on FireBeetle board from the FRobot, and it works pretty much the same because again this is a generic C++ library, and what we are going to see here, the actual code from cpplinq, also works outside the scope of microcontroller programming. So obviously, the statements that we are going to use that are related with serial connections don't work in general C++ programming, but all the rest, all that is related with cpplinq, can be used in general programming. So, as I was saying in the previous tutorial, we covered a very simple use case where we got the first element of an array. So it was very simple. Obviously, it doesn't make sense to use a library just to do that. But now we are going to enter in more complex use cases. But we'll get there in a minute. So we are going to start by analyzing our code. So as usual, like we did before, we need to include the cpplinq library in order for us to have access to all the operators that this library makes available, and then we need to use this using directive to indicate that we are using the cpplinq namespace. This is optional, but it's very useful, so we don't have to always specify when we call the operator from cpplinq. We don't need to always be specifying the namespace to which they belong. So this is just to make the code below a little bit more compact. And then we are going to write the rest of the code in our setup function. Before we start analyzing the setup function, let me just say that the use case that we are going to cover is getting the first element of an array that fills a given criteria. And for this simple tutorial, our criteria will be finding an element that is even. Okay, so basically we want to get the first element from the array that is even. So obviously, we can specify other conditions. So this is a condition we have chosen, but as we are going to see, we'll have the freedom to specify whichever condition we want. So moving on to the setup, where we are going to write the rest of the code. As already mentioned, we start by opening a serial connection, as you can see here, so we can later output the results of our program. And then we are going to define an array of integers. As you can see here, it's an array with some arbitrary numbers, but the first even number that we have in our array is this 4. Okay, so basically, if everything goes accordingly to what we are going to do, to what we want to do, we should obtain this number here 4 as output of our program. Okay, because it's the first even number of our array. So then, going back a bit to what we have talked in the previous tutorial, before we get started to apply the cpplinq operators, we need to convert our array to a range object. So all the operators, the cpplinq operators, need to be applied over a range object. And it's really trivial to obtain a range object from our array of integers. So we have our array, and we have here this operator called fromArray that receives as input an array, and it returns a range object representing that array. After that, and also as we have mentioned briefly in the previous tutorial, we can chain other operators, other cpplinq operators, using this operator here. Okay, so this is overloaded, and thus we can chain multiple operators. This is a very simple use case where we convert our array to a range object, and then we want to obtain the first element. But there are more complex use cases, like we want to first do a filtering, then we want to do an ordering, and then we want to obtain the first 4 elements. So this can all be chained with this operator, giving more complex expression trees. Obviously, for these introductory tutorials, we are not going to cover it, but we are going to get there in future tutorials. So we have already seen this operator, the first operator. in the previous tutorial we called it without passing anything as input, and we have obtained the first element of the array unconditionally. Okay, so if we call this without arguments, we just get the first element of the array. But this operator is a very powerful one because it can receive as input a function. Okay, and what this function will specify is the criteria that we want to check against the elements of our array, and as soon as an element fills our criteria, that element will be returned. So basically, this is an high order function because it receives as input another function, and that function is going to specify our criteria. So in terms of working with cpplinq, obviously we can declare named functions and pass as input of these operators named functions, but it makes the code a little bit more much less compact, because we would have, for example, to have here a name function, and then so we are applying the operator here, and we don't see right away what is the operation that is being done. We need to go look to the function, and that it's a little bit not so easy to understand, I would say. So there's a very nice syntax which is called the Lambda syntax, which basically allows us to define anonymous functions in C++. This kind of concept is available in many other programming languages, and C++ is one of them, where it allows to define what is called a Lambda function. That is basically an anonymous function that we declare here in line. So it's not named. So, for example, in this case, we cannot reuse it, but for our use case, it doesn't make sense to reuse our function. So it's totally fine to declare it in line anonymously, because the only purpose is being used by the first operator. So if you are not acquainted with this Lambda syntax, I'm going to leave in the description of this video a link to a resource that explains a little bit better how it works. But basically, in terms of syntax, there are some variants of the syntax. We are going to analyze this variant that I'm using here, but basically this first empty square brackets corresponds to the captures of the Lambda function. We are not going to make use of them, so for now just take in consideration that we need to declare here, to put here these two empty brackets, but we are not going to put anything inside because we are not going to need them. Then the second thing we need to do is basically declare the arguments of our function. In our case, we are going to receive an integer, and I'm going to explain in a minute why we are receiving an integer. And then after we specify the arguments, obviously we could have here multiple arguments. We just need one for our use case, but we could have more. Then inside curly brackets, we simply define the body of our function, and that should be it. So the compiler will infer the returning type of our lambda. We could also explicitly declare it, but in this case, for a shorter syntax, the compiler will infer the returning type. So basically, this is the syntax that we have to define our function. Pretty simple. It's a little bit of a different concept for people who are seeing this for the first time, but it's really powerful and really useful when working with cpplinq and in many other use cases. Now, going to the actual signature of the function that we are using. So the idea behind the first operator and this function is the following. So basically, this function that we are going to declare here, it will be executed for each element of our array. So imagine a simple implementation would be doing a for loop over our array, and for each element of our array, so this function will be executed. Okay, but as soon as and to complement a little bit, so the body of this function basically needs to implement our criteria. Okay, and it should return true if that element, the element that it received, fills our criteria. Okay, so we'll execute this function over all elements of the array, and as soon as one of those elements fills our criteria, so in other words, as soon as our function returns true, the first operator will take that element and will return that element, because we want to get the first element that fills our criteria. Okay. And as I was saying, we indicate that the element that is being evaluated fills the criteria by returning true from our function. Okay, so our function receives as input an integer, which is the current element under evaluation, and returns a Boolean value indicating if the condition that we want to implement is met or not. So we have here our element, so the element under evaluation, and as I said in the beginning, we want to check if the element is even. So the easiest way to do this is checking if the remainder by 2 is equal to 0. So this is the traditional and standard way to see if an element is even. So, and if it does, since we are doing a comparison, it will return true and indicates, okay, this is an element that fills our criteria. Otherwise, it will return false. And that's just it, okay? So this is very simple in terms of what we are going to achieve. There are here a couple of new concepts, Lambda functions, the cpplinq operators. But after we get past this slightly different syntax, the concept is very simple, okay? And that's it. So this element will already return an integer that we are going to store here in this variable called result. And then at the end, we are going to print our result here to the serial port and check if it matches what we are expecting. And that's it. That's it. Again, it may seem a little bit complex at first if you are not familiar with this kind of programming, but I can say that after a while, this becomes very easy to read. So someone that is acquainted with this type of syntax, and this is something that exists in, for example, in C# with the LINQ syntax. In JavaScript, you see also a lot of operators similar to the ones that are offered by cpplinq. And as soon as you start getting the hang of it, programming becomes much cleaner, much clearer. And easier to understand. Obviously, at first, for people who are not acquainted with this, it's a bit complex to get acquainted with the concept. Another word of caution is obviously this is something that we are doing in a microcontroller. Obviously, all these operators have overhead, so you need to ponder if for your application it makes sense to use this kind of programming or not. Obviously, I'm presenting this because I think it's important to know more programming concepts, other ways of doing things. But depending on how your application works, on the resources you need, it may not make sense, obviously, to go to fetch a full-fledged library to do all of this. And obviously, you can also do this with for loops. The code gets a little bit more complex, but probably it's for some people it's easier to understand. It should also be more efficient if you stick with old for loop. But obviously, this way it's also feasible because microcontrollers are getting more and more powerful. So depending on the application, again, I'm not saying this is right or wrong, but it may make sense or it may be interesting to explore these cleaner ways or simpler ways of programming. And that's it. So I'll leave to your consideration to analyze your application to see if it makes sense or not. And that's it. So as you can see here, I'm printing the result. I've already uploaded this code to my device, and I've already run it here. But I'm going to reset it, and so it runs again. And as you can see here, we obtained the element 4. So as expected, it skipped 5, it skipped 7 because it doesn't fill the criteria. So when we were evaluating the first two elements, this function returned false. And as soon as it hits here the value 4. So this condition here is, sorry, let me highlight it. So this condition here is true. It will return true. And basically the first operator knows that we found the element we wanted, and it will return. So for those of you that might be curious about what happens when the first operator doesn't find an element that fills the criteria, so it basically throws an exception. Okay, this is because in some kinds of programming we want that we are sure that we always have an element of the array that should be returned. It's a common approach that we use, for example, this first operator to throw an exception because that should not have happened. So to throw an exception if no element is found. If it is possible inside the logic of your program, if it's something that is expected that you don't find any element, there's another version of this first operator which basically returns a default value in case no element that fills the criteria is found. Obviously, that's another use case. We eventually will cover it as well, so we are aware. But do be careful. Be careful if you use this first operator, because if you are not sure if you are going to find an element that fills the criteria, and if you do not find it, it will return an exception. And that's it. Again, this is a slightly different way of programming, of operating over arrays. Personally, I think it's very clean. Again, I'm covering this in microcontrollers, also a lot by curiosity to see until where we can push the boundaries of the ESP32, of the ESP8266. It's also for curiosity, and because it's funny. Obviously, in real application scenarios, in many cases it might not make sense to use this. In other cases, due to the fact that these are powerful microcontrollers, eventually this might also make sense to use on a real scenario. Obviously, it all depends on your use case. And that's it. Thank you very much for watching. Hope you have enjoyed.